Hi, let's continue with our section. In this video, we'll perform clustering using sklearn. So clustering is a collection of unsupervised machine learning algorithms in which parts of the data were grouped based on the similarity. So let's write the definition for that. So clustering is a collection of unsupervised machine learning algorithm in which parts of the data are grouped based on similarity. So for example, cluster may consist of data that is close together in n-dimension Euclidean space. So clustering is useful in cybersecurity for distinguishing between normal and anomalous network activity and for helping to classify malware into families. So let's write some text for that. So clusters may consist of data that is close together in n dimension no Euclidean space. Clustering is useful in cyber security for distinguishing between normal and anomalous network activity and for helping to classify malware into families. So now we will perform clustering using the scikit-learn. So first, I did import the Google Colab and then I did mount the drive, and you can see that I did mount it at the content at the drive. And now I just cd to the Colab notebooks. So now we just start by importing and plotting the data set. So start by importing and plotting the data set. So now we need to import pandas as PD, and then we need to import plotly dot express. So this one is the plotting library as px. So let's run the cell to see we have any error. So I hope we don't have any error. And now we just write pdf equal pd dot read underscore csv. So we don't have any error. And now this one is just read the data. So file underscore pe underscore header dot csv comma set equal and then comma, and now you just use fix equal px dot scatter underscore 3d. So now we have is df comma x equal suspicious import functions, and then comma we have y equal section length, and comma color equal malware, and then comma and finally we have fix dot show. So let's run the cell to see what is happened. So I did successfully plot the I did fix the error, so we can fix figure equal bx. So this is a formula come from the plotly.express library. So we dot bx equal dot scatter 3D. So this is a function that plot a 3D, and then we put the data frame in with the y-axis equals suspicious import functions, comma, and then the x is suspicious import functions, y is a section length, z is a suspicious name section. So because they are 3D, so we have x, y, and z, and color equal malware, and then comma, and then fix dot show. So this is our result. So as you can see, if you hover it, you can see there is a suspicious import function is 0, section equal 12, suspicious name section equal 0, and malware equal 0. However, if we hover to the 0, we have malware equal 1, and then if we go through, so if we go to here, we have a suspicious import function is 27, section length is equal 26, and malware is equal to 1. So it's a very good graph. So you can jump in and you can jump out as well. So you can see on the point here is in a 3D. And now we can extract the features and the target labels. So let's write some code for that. Extract the feature and target labels. And now we have y equal df. We have is malware. And now we have x equal df dot drop. We have name, comma, malware, and then we have axis equal to 1 dot 2 underscore numpy. So we just run the cell. So now we will import a sklearn clustering module and feed k-means model with 2 clusters to the data. So now we'll have is from sklearn dot cluster will import k-means. So and now we'll have a estimator equal k-means. K-means. And then we have number of cluster is n underscore cluster equal to length. And then we have set y. And now we have a estimator dot fit. We have x. So let's run the cell. So I change it to x small n, and as you can see, there is a k-means which is algorithm is equal auto. Copy x is 2, and then number of iteration is 300. So now we will predict the cluster using our train algorithm. So we need to predict the cluster using our train algorithm. So we have y under breadth is predict. We have estimator dot predict, we have x, and now we have df is bread equal y underscore bread, and now we do the same thing, so just copy and then paste here, equal df bread dot as type will have is category. So let's run the cell, and now we will see how the algorithm did and plot the algorithm clusters. So we will do the same. We just copy here the code that we wrote before and then paste here. So fix dx dot scatter 3D, we have df x y, and now we will have color equal red, and now we have is fix dot show. So let's run the cell. Just wait for a bit, and now we got our result. So the results are not perfect, but we can see that the clustering algorithm capture much of the structure in the data set. So we have bread equal 0 and bread equal 1 here. So that is a really good plot. And how does it work? So we start by importing our data set. PE had the information from a collection of samples. So let's write some steps for that. So it's really annoying when you have to jump in and jump out. So let's write some steps for that. So step 1 is we import our data set of PE had the information from a collection of samples. And now this dataset consists of two classes of PE files, which is the malware and binding. So this dataset consists of two classes of PE files, which are malware and pinning. So we can use Plotly to create a nice looking interactive 3D graph. So we did use Plotly to plot 3D graph. And then we proceed to prepare our dataset for machine learning. And in step 2, we set, so in step 2, we set x as the features and y as the classes of the data set. So based on the fact that there are two classes, we aim to cluster the data into the groups that will match the sample classification. So we set y on cap block. So we set x as the feature and y as the classes of the data set. So we aim to cluster the data into two groups. that will match this sample classification. And then in step 3, we utilize k-means algorithm. So with a thoroughly trained clustering algorithm, we are ready to predict on the testing set. So we apply our clustering algorithm to predict to which cluster each of the samples should belong. So with a thoroughly trained clustering algorithm, we are ready to predict on the testing set. So in step 4, we apply our clustering algorithm to predict algorithm to predict to which cluster each of the samples should belong. And step 5 is we see that clustering has captured a lot of underlying information as it was able to fit the data well. So this is and that is all in this video. So I hope you can successfully plot the graph, and of course you got the same result as me. And that is the end of this video, and I will see you in the next video.